The advent of special relativity drastically altered the way we viewed our world and paved the way for revolutionary advances in physics. But where exactly did it come from? To answer this, we have to look at the history of light, and more specifically, how light travels. It had been suspected since the ancient Greeks that light did not travel infinitely fast. However, the first notable demonstration of this was made by the Danish astronomer Ole Romer. Romer noticed that when Jupiter is farther away from Earth, the eclipses of its moons lagged behind the predicted times, and when Jupiter is closer to Earth, the eclipses were ahead of schedule. Using this, he was able to estimate the speed of light to within about 25% of what we measure it to be today. However, it was not until the end of the 19th century that this really made an impact. At this point in time, the theory of electromagnetism had been thoroughly studied and a lot of great leaps had been made in the subject. Most importantly to this topic was the discovery that light was really just a propagating electromagnetic wave. While this seemed to be correct based on the predictions that it made and their agreement with experiments, there was one major problem. You can find that these waves can exist in the absence of sources. Put in other words, light does not need a medium to propagate through. But why is this a problem? Well, up to this point, waves had always had to travel through something, whether it be air, water, or stadium crowds. When figuring out how fast the wave travels, it is generally assumed that the medium it travels through is stationary. This implies the existence of a quote-unquote correct reference frame. You can move relative to the medium and see the wave travel at a faster or slower speed, but that is just an artifact of you moving, since the medium looks like it's moving as well. However, if no medium exists, there's nothing to move relative to, and so a correct frame of reference cannot exist. But this means that waves of light had to move at the same speed in every reference frame. Let's take a second to digest this statement. Imagine Isaac is standing on a planet and Albert flies by at very fast speeds in a spaceship. Now, as he passes Isaac, Albert shoots a pulse of light past Isaac. Isaac sees this pulse of light and measures its velocity. At the same time, Albert measures the velocity of the light, and they find that the velocity they measure is exactly the same, despite the fact that Albert is moving relative to Isaac. This completely contradicts what we found in Galilean relativity, namely that velocities were additive. This one simple idea that the speed of light is constant has massive ramifications, since all of the physics done up to this point had been assuming that Galilean relativity was correct. It meant that a lot of the physics done was incorrect. But how do we fix it? As it turns out, we have to change how we look at space and time to create a theory which is consistent with these discoveries.
Please subscribe to my channel, QuantumData Verse. Thank you.